Welcome back, inventors. I am Jatin Kumar Malik, and today we are at day 21 of our Advent of Code 2024 series. Yesterday, we helped a bunch of programs to cheat through their race condition to get from start to end very quickly. And if you are new here, I am a principal engineer who absolutely loves solving these puzzles every year. Last year, I wrote like a whole blog post series on Medium, and this year I'm doing YouTube so that I can get a bit more close to you and explain you how to think behind the scenes for a problem and how to approach it, how to solve it manually first by doing dry run using a pen and paper, and then getting into writing code for that. And if you haven't check out our last 1 to 20 days playlist right here. And since today we are at day 21, if you notice the shape around my face cam is ICO-C Hexagon, which is a 21 side polygon. And believe me, it looks very close to being a circle, but if you zoom in enough, you will see that we are still stuck inside a polygon. And if you have been following this series, I think around day 10, I made a prediction that by day 22, the shape around me will be completely indistinguishable from a circle. And I think we are approaching very close to that. But with that, let's read the day 21 problem and let's get started. So the day 21 problem today is called Keypad Conundrum. Let's read it. As you teleport onto Santa's reindeer class starship, and this seems like a reference to 2019 day 25, the historians begin to panic. Someone from their search party is missing. A quick life form scan by the ship's computer reveal that when the missing historian teleported, he arrived in the another part of the ship. And in the last episode, we had this last episode, we had this tone from the game Among Us. I think if it has something to do with that. But let's read forward. The door to that area is locked, but the computer cannot open it. It can only be opened by physically typing the door codes, your puzzle input. So our puzzle input is a code to open a door, and I think that is to the another part of the ship. The numeric keypad has 4 rows of button, 7, 8, 9, 4, 5, 6, 1, 2, 3, and finally an empty gap followed by 0, 1. Visually, they are arranged like this. So let me copy this here in our whiteboard so it's easy to talk. And let's keep that here. And okay, so it's like we are given a keypad and we have this empty space, but we have 0 to 9, and then we have an A button. Let's see what that is all about. So unfortunately, the area outside the door is currently depressurized and nobody can go near the door. A robot needs to be sent instead. So we need to send a robot to press some buttons for us to input this code that is given to us. So this code will probably go here. The robot has no problems navigating the ship and finding the numeric keypad, but it is not designed for button pushing. It cannot be told to push a specific button directly. Instead, it has a robotic arm that can be controlled remotely via directional keypad. Interestingly, so we have a robo which can be controlled by a directional keypad, and we are given another keypad. The directional keypad has 2 rows of button, a gap, up, activate. Oh, so A means activate on the first row, and then the left, down, right on the second row. Visually, they are arranged like this. So if I copy this, this looks very much like your generic keyboard arrangement, but with the exception that we have an activate button. And it seems like this is controlling our good friend Robo. So I took some liberty of downloading a Robo. So let's pick this one. And let's get them here. And it seems like using this keypad, we can give some commands to this Robo, and then this Robo enters those commands here. So this seems fair. And here we know left, right, up, down, and then we have an activate button. Okay. Let's read more. That's an interesting problem. So when the robo arrives at the numeric keypad, its robotic arm is pointed at A button in the bottom right corner. So I think I can just modify this arrow. And it's saying that when initially the robo starts moving, it is pointing to A button here. And after this, the directional keypad remote must be used to maneuver the robotic arm The up, down, left, right buttons cause it to move its arm one button in that direction, and A button causes the robot to briefly move forward and press that button, being aimed at by a robotic arm. Very interesting. So for example, to make robot type 029A on this numeric keypad, so if let's say our target is 029A, what you could use is, you can use the sequence of the inputs on this directional keypad to get this. So we are starting from A. So first we can press this button to go left. So now my robotic arm should point here, but it's not going to press it yet until I press A. And it sets its initial position to 0. And then you press A to push the 0 button. So you press A and that presses this button. Okay, fair enough. And then you need to press 2. So if you see 2 from here is up, so most likely we go up and then we press activate, and then it goes up and presses the 2 button. And then you have to go from 2 to 9. And now I can see that if you want to go from 2 to 9, there can be two multiple ways. Either I can go up, right, multiple ways actually, or I can go right, up, or in fact, I can also go up, right, and up. Right? So I think, let's see, which one do we have to pick? So for now, let's pick any one. So for this example, it says that you will go left, up, and up. So we go left, up, and then we press A. So it goes, it goes right, up. So it goes right, up, and then activates, which means it presses 9. And last, we have to press A on this keypad, which means that from here we can just move down, 3 times. So which means down, and we press activate, which says here, like down, and activate. And this will activate our code and it will do that. So in short, there are 3 shortest possible sequence of the button presses on this directional keypad that would cause the robo to type 029A. And I think these 3 are the exact 3 cases I was talking about. So if I have to use 3 different colors, I think from this 0 to A to 0, there is only one path, which is the shortest. And 0 to 2 is also one path, which is shortest, where you go up and press activate. But 0 to 9, we have 3 multiple paths. So either I can go like this, or from here, I can go like this. And if I take another color, the third one, where I can go like this, and then this. And then from 9, again, when we are coming back, there is actually just one shortest path where you will just go like this and then you will press this. So I hope that makes it a little clear. So now it says, unfortunately, the area containing this directional keypad, which is this one, is currently experiencing high levels of radiations. I see where this is going. And nobody can go near it. And our robo needs to be sent instead. Very interesting. So this reminds me of Inception. We are in a dream inside a dream inside a dream. But anyhow, let's read that. So yeah, if I had to clean this and then explain it again. So it says that like we cannot really press these buttons ourselves. We need to send another robo. So let's send another robo. And now this robo is here. And if I had to just make this a slightly simpler. Okay. So let's read that. So when a robo arrives at this directional keypad, its robotic arm is pointed at the A button in the upper right corner. So now if I had to draw another arrow for this robo, so maybe I can use the same color. Let's use white. And now when we arrive here, so this robo is also now pointed at A. And how do I control this robo now? Probably there is another numeric pad. And of course, after that, a second different directional keypad remote control is used to control this robo in the same way as the first robo, except that this one is typing on a directional keypad instead of a numeric keypad. Interesting. And it is pointing towards here. So which means that I have to probably make another copy of this here. And then we have this keypad that is controlling this robo. And this robo is initially now pointing to this. Exactly. So there are multiple shortest possible sequence of directional keypad button in the presses that would cause this robo to tell the first robo So let's give them some numbers. So this one is the first robo. This one is the second robo. And this will tell first robo type 0291 on the door. One such sequence is, so we are given another sequence. So let's look at that now. So now instead of directly typing here, we are typing here. And remember, this robo is starting from A and this robo is also starting from A. So now if I have to press just 0, we have to go back 2 levels. To type 0 for the first robo, I have to press some keys here where we identified that we have to press the left key and this press activate. But now just to get to the left key, we have to probably press a series of move here where I can either go like this, or the other move is I can go like this. So let's write one of the paths down, and I think it says the shortest sequence, but in this case, since this is a grid, this will cover 3 tiles and this will also cover 3 tiles, unless there is some penalty on turning, but I don't think like that, but let's see. So now from here, even just to type my 1 0 key, which means basically this robo has to, so on this keyboard, what I want to do is I want to emulate go left and press A, basically go left and press A, which means I will have to here press go left, go down, go left and press A, which means go left, go down, go left and press A, which will just press this first key. And then to press the A back again so that it can dial the 0 here, I will have to go back here. So I will have to go right. So go right, go up, go right and press A. And I'm typing all of these things here. And then this will type my A function. And there, I think this is given a similar sequence where they have given the initial sequence where you go down, go left and press A. So they are taking this path. If I have to use another color, if I copy this, it's saying like go down, go left and press A, which is giving a sequence here that go down, go left and press A. And then it is saying, if you see here, like right up A, which is right up A, which means like right up and then A, which is basically then parsing this one. And then there we are given a whole sequence here. Very fascinating. So let me lock this and clean this so that it's easy for us to draw and delete things from it. So I'll take the eraser and then I'll just delete this. So this is clear to me. And now it says that unfortunately the area containing this second directional keypad remote, which is this one, let me pick the same color, which is this one, is currently under minus 40 degrees. What was the last one? So last one had a lot of radiation. So just for the kicks, let's see. And what was the first one? So the first one was depressurized and you could not do something. So this is depressurized. This one has radiation. I just marvel at the creativity of Eric when he's designing this. And this keypad is at minus 40 degree. I don't know the unit, so I'm going to assume Celsius because I'm from India and we follow Celsius here. Although I am in the US now and I should start doing Fahrenheit, but okay. So yeah, I'll leave it like this. And now you cannot type buttons here as well. So it seems like I have to, what do I do? Send another robo. So it says that another robo will need to be sent to type on the directional keypad too. So good thing I have a lot of robos here. So let's send this robo here. And this robo is already irritated by all the calculation and combinations that he has to do. And this robo is also pointing to this directional keypad. It doesn't say here, but I'm going to assume that that is the case. So it seems like that this robo is now also pointing to the A key. And how does this robo knows what to do? Of course, we have to take this and I have to unlock this so I can move it. So I want to keep everything in one screen. So I'll just move everything a bit down so we can see all 4 keypads. Let me lock this one as well. And if I draw an arrow, now this keypad here is telling this robo like what to do. And let's just clean this a bit. So let's move it down and then take this robo and oops. Let's take this robo and move them up. So this robo is pointing to the A key, and then this robo is getting their instructions from this keypad, that is here. Fair enough. Okay, let's see that. So after doing all of this obfuscation on third level, so that's important. So this is the third level. So now we have 3 robos here. And now there are many shortest possible sequences of the directional keypad button presses that would cause this robo to tell the second robo to tell the first robo to eventually type 029A on the door. And one such sequence is, and then we are given a sequence. Now remember, to type 0, this robo has to go left and press A, which means this robo has to go left and press A. But for this robo to go left and press A, here we have to go to left, we were following this path, which was you have to go to left, down, left, A, which just sends this. And then it says right, right, up, A, which was basically allowed to type this, which just allowed us to type one single O, 0. And now for me to evaluate this left here, where I have to tell this robo to do something, which is pointing to A, it's like a bit of a recursion, but to go left here, just to give one left command, I have to do the same thing here, where we'll have to go left. So I'll have to go left, down, left, which is left, down, left, and press A. And this will just get the robotic arm here, but it will not press it unless I go back and press A, which means I will have to go right, right, up, A, which means I'm going like right, right, up, and A. And when I press this, this will just press this first command, that is here. So you can see how we are basically, if you were to draw a tree at each level, it is actually in a very interesting way tree in my head, where each move is exploding into another combination of moves. And then we have multiple ways of getting to that move, but we need the shortest possible way. And then this whole thing evolves into this bigger bit. But let's see if there is another layer, like who is typing these commands now? So unfortunately, the area containing the third directional keypad remote is currently full of historians, which is us. So no robos can find a clear path there. Instead, you will have to type this sequence yourself. So, okay. So this is basically our real input that we are doing. So if I had to draw an arrow, finally, it's basically us. So do we have a human here? Let's see. Okay, I find a user. This should do. So we have a user. Actually, you should just call it you. So you are giving the input on this keypad, which is in turn giving a note to this robo, which is putting input on this one, which is asking this robo to input on here, which is asking eventually this robo to do this. And our goal ultimately is to type this that is given here. So were you to choose this sequence of button presses, here are all the buttons that would be pressed on your directional keypad, the two robos directional keypad and the numeric keypad. And I think this is obfuscating the same thing that we drew. So if I type this whole sequence that is given here, it will type this sequence on the second. It will give this sequence to the second robo. It will give this sequence to the first robo. And then finally, our first robo that is here will type 029A. So in summary, there are the following keypads: one directional keypad that you are using, which is here, two directional keypad that robots are using, and then one numeric keypad on the door that a robo is using. And see, when you draw these things, it just makes it a lot more simpler to understand what's happening. Else this problem gets very confusing very quickly with a bunch of operations that looks like these angular brackets for directions and then bunch of A presses. So it is important. Let's see what we have to do now. So once we do this, what is the answer? It is important to remember that these robos are not designed for button pushing. In particular, if a robo arm is ever aimed at a gap where no button is present on the keypad, even for an instant, the robo will panic unrecoverably. So don't do that. All robos will initially aim at keypad's A key, which we are given here. So if I had to do this with a green one, let me clean this. Yeah, so this is the initial position for each robo. And I'm assuming we are also going to start here when we start doing the presses. And yeah, so I think the very, very interesting thing is that you have to never go here. So this is a no-go position. Like when you are doing the pathfinding, our arm can never go on this. Basically, you can imagine if you have solved the last few days, it's another grid problem hidden behind all the complexity of the language. But it is very similar that this is an obstacle. And like when you are finding your path through it, you cannot go here in very simple terms. So to unlock the door, 5 codes will need to be typed on its numeric keypad. And then we are given 5 codes here. This is our test case. For each of this, here is the shortest sequence. So I think I'll write it down. So I think what we have to do is we have to find the shortest sequence here. Shortest sequence on the third keypad, fourth keypad, or third direction pad. We have to find the shortest sequence that you can type to cause the desired code to be finally typed here on the numeric keypad. And then we are given an example for 029A, 980A, 179A, 456A, and 379A. So I'm not going to dry run all of them, but I think to build a very solid understanding, you should basically draw keypads like this and then decipher at least 2 of these test cases. So pause the video right here and try to do it. That will help you to build a very solid understanding of this question. So the historians are getting nervous. The ship's computer does not remember whether the missing historian is trapped in an area containing a giant electromagnet or molten lava. See, there is no in between. It's never simple with these people. It's either an electromagnet or a molten lava. You will need to make sure that for each of the 5 codes, you find the shortest sequence of the button presses necessary, which the question has done here. And then the complexity of a single code like 029A is equal to the result of multiplying these 2 values. So let's scroll down and get some space. And so we are saying that there is something called complexity that we have to calculate. And this complexity is equal to multiplying these 2 values. So it is the length of shortest sequence of a button press you need to type your directional keypad in order to cause the code to be typed on the numeric keypad. For 029A, this would be 68. Okay, so it's basically the length of this whole sequence. So it is length of the sequence for one code. So I'll write shortest sequence per code. So this is for 029A, multiply by the numeric part of the code, ignoring the leading zeros. So for 029A, this would be 29. So this is the numeric part of code. An example is, this is 29. And for example, this one example is given as 68. 68 is nothing but length of this particular instruction set. And when we multiply this, we are given an answer. So we will do 68 by 29, 60 into 980, and so on. And then our final answer comes to 126384, which is 126,384. So now it says that find the fewest number of button presses you will need to perform in order to cause the robo in front door to type each code. What is sum of complexities of the 5 codes in your list? So, and then our answer is, once we calculate this, we need to do a sum of these complexity for all codes that are given. And let's see our puzzle input. So our puzzle input also has 5 codes. So I think initially we can see that for part 1, while there is a 3-level hop in your traversing logic, but it's still not as crazy yet. Probably that is reserved for part 2. That's what I'm expecting now. So yeah, I think this is a time where you should pause this video and you should think. And I think it's very important for you to build the understanding of the code and then try to think how would you solve this problem. And doing a dry run is always the most excellent step to start. And once you are back, we will discuss some of the hints on how I am thinking of approaching this problem. And we'll talk about that. See you in a bit. And yeah, if you're looking for hints, let me make some space and grab our hint marker. So I think overall, if you have built an understanding of the problem, you can see that there is a lot of misdirection hidden behind layers on what we want to do. And here are some of the approach that will help you write some code. I think one of the first most important thing that we need to understand is, and that will aid in how you write code, is how would you want to represent these keypads that we are given, and then we are given a direction pad. And eventually, if you look at this, this is yet another grid, and we have to basically traverse the grid and press some buttons and do that. Once you're able to do that, you need to be able to have a way of finding the shortest path between your source and destination. And if you have been following advent of code, does some algorithm comes into your mind? Yeah, of course. So I think since this is an unweighted graph, the first thing that comes into my mind is BFS, which is our breadth first search. We don't need to go crazy and use digextra or anything because these are unweighted graphs. So there is no penalty so there is no approach where you need to optimize for that. All you need to optimize is that how to reach from source to destination in the shortest moves possible. And once you do that, I think your second thing is how would you solve this problem? And here I think breaking it into smaller problems, and then solving individually for Robo 1, Robo 2, and Robo 3 will help you a lot. And if you look at this discussion that we had above, there is a simple hint hidden, I think, in all the dry run that we did, that whenever you solve for Robo 1, where you get like bunch of directions you need to simulate this, the output of finding this becomes the input to find this. So this becomes input, and then you need to output this for the second robo. And then similarly, the output you get becomes input for your third robo. And similarly, at the end, this your output here becomes the input for you, which is also, since it's a code, it's a robo, it doesn't really matter. But in this way, you can have a function that can remain common actually, and it can do this multi-stage operation where the fourth part is you, where every time you get an answer like output, it becomes input for your next puzzle, and it becomes input for your next puzzle, output, and then finally you get the answer, which is not directly answer, you get the sequence, and then from that sequence you can calculate the answer. And this is very powerful. Like if you try to think in this terms, you can also reuse a lot of functions, because essentially what you are doing is you have like a simple find sequence function where you are passing two things, where you are passing a grid, which can either be the numeric grid or the direction keypad, and then you are passing like what you want, the pattern in a way, pattern or code that you want. And this can give you sequence. And now what you can do is you can just call this function either recursively or iteratively in this set. And once you are done with 3 iterations, you get out and you will have this long sequence. And yeah, once you get this, you do this for all 5 codes. So it's basically 4 level deeps for 5 codes, so 20 iterations. And I think by doing this, you should basically have the answer. And you might also want to think about when you're finding this, there is one edge case that we have to remember, that empty space needs to be ignored. And I think this is where a lot of people will make mistake, where once they run BFS, because it's very symmetrical, the direction pad and the keypad that was given to us, it is very easy to make mistake like that. There was one more row because there was 0 and A where we had to ignore this and where we had to ignore this one. So good thing would be to generate a symmetric grid and then just put like a blocker here, maybe a hash or maybe a cross, and then add a condition that when you're doing your BFS, you just cannot go there. And with this, I think I'm going to go ahead and write some code, and it's a good time for you to pause the video here and try to write some code yourself as well. And yeah, once we are back, we will do a quick retro to see what else optimization I was able to discover while solving for part 1. But I think this should do really well for us. So I'll see you in a bit. And welcome back. As you can see, we have found our first gold star and we are closer to finding the chief historian. And if you don't know what's that about, so if you check the whole series from day one, we have lost the chief historian and I have been trying to help these elves to find him so that we can save some Christmas. And in terms of retro, I followed the exact same thing we talked about in the hint. So if you can see that there is this chain of commands that we are doing and we are trying to do that. And I think one of the things that helped me was to create this generalized method. So I initially thought that we can brute force it because it's we only had 4 codes to solve and uh, following by 3 different patterns. It wasn't really a lot of operations for us to do. But finding the path increasingly becomes complex because as we talked in this example above, here just to find one press one key you have to give 2 commands here, but then you have to give 8 commands here and then it increases exponentially on this level. But yeah, once we were able to find this generic sub problem, it just became easier because I can just feed the input to other one, and I did this iteratively, but I could have also done it recursively. But yeah, with this I think it's time for us to move to part 2 and let's read it. So we'll make some space and I'll hide the answer here because I want you to try it yourself. And also anyways, there are multiple sets of inputs, so that will not directly help you anyway. So it says that just as the missing historian is released, the historians realize that a second member of their search party has also been missing this entire time. Whoops. A quick lifeform scan reveals the historian is also trapped in a locked area of ship, and due to a variety of hazards, the robos are once again dispatched, forming another chain of remote control keypads, managing the robotic arm wielding robots. Interesting. So this time, many more robots are involved. In summary, there are following keypads. So we have one directional keypad that you are using. So I'm just going to draw it directly without going too fancy. But we have this one directional keypad that you are using or we are using. And then there is 25 directional keypads that robos are using. Okay. So then, if you see, I can maybe put some robos here. So we have this guy, we have this guy, we have a few robos, this guy, and we have, let's say, this one more guy. And if I see, so there are total 25 robos here that are forming the chain, which is basically passing the commands to each other. And finally, we have our that big 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there was 0, comma, A, if I'm not wrong. Yeah. So that is there. And then that is being finally managed by our final robo, where we are getting this final instruction here, and this guy is just punching in our codes that are given to us as input. And yeah, the keypad forms a chain just like before. Your directional keypad controls a robo, which is typing directional keypad, which controls a robo, and like this is forming this chain. The door codes are same this time around. Only the number of robos and directional keypad has changed. Find the fewest number of button presses you will need to perform in order to cause the robo in front of the door to type each code. And what is the sum and the complexities of 5 codes of the list? So our input puzzle is still the same, but we have to go through all of this chain to find the final answer. And then from here, I think we can get the answer. So problem is fairly similar, but you can see that the complexity has increased quite a few folds, because initially we only had 3 robots in this whole chain of commands, but now we have 25 robots in between, and then we have the final one, which is 26 robots that are finally trying to form this so that we can save the missing historian. And with that, I think it's a good time for you to pause and think about the problem, that depending upon how you solved your problem for the part 1, this may be simple and it may be infinitely more complex for you. Because if we were brute forcing initially, now the brute forcing is going to be insanely hard because the sample space is going to go really huge, and you have to think about that. So you have to probably learn from the learnings and the retros and the hints that we gave in part one and see that if we can write like a very optimized solution for this so that we can have a reasonable runtime and get our answer. And yeah, so pause now, think about it. And once you're back, I will talk about some of the hints. And yeah, hey, if you are here for the hints, let's talk about them. So if you see, based on what we discussed in the hints above, I think one of the most important things here, it is the classic DP question where you have to identify the subproblem and then see that how you can do it n times efficiently. And when I say efficiently, it almost 100% of times it means like having some kind of a memoization in the mix, which means like we need to have some kind of a cache. And I think that should be all we need to do if you are able to find the sub problem and break the solution down so that you can just keep calling that. And to explain this in layman terms, if you see, so we are given a bunch of directions like this, and then we are given like this in a chain where we are trying to find this, and then we have an A button here and we have an A button here. And now, and we are traversing from the first solution. I remember I told you that it will be really easy for us because if we were able to find like what is the set of commands that the final robo needs, we can then back propagate it to understand like, oh, so what does this needs to press and then what this needs to press. And if you see here, like when we are calculating these directions, so let's say there is the robo n and then there is robo n minus 1. And when this robo has to control this, for any given command, let's say if I have to ask this robo to go left, and it is starting from this position here, the command that this robo will give would be like go down, go left, and then you will point to this, and then you have to press A, enter, so it will press this left key bar. And if you go back and if you see, like just to make this robo to go left or go down, what does our n minus 2 has to give this robo? You can see that there is bunch of instructions and sub instructions that are repeating itself within the pattern. So whenever there is left button called and you are at A, there is exactly one way to do it, the shortest way, right? You can either go like this, or you can either go like this. And the idea here is that if I cache a simple source destination for all the 25 robos that are here in between, that are just giving instructions to one another, it will be really fast for me to do that and calculate this whole giant pattern by using my cache so that I don't have to invoke my BFS again and again and again. So essentially all I need to do is I need to have one PFS for my numeric keypad to initially find the directions. And then for in the chain for 25 and even 26, because we are also using the directional keypad here, I can just use my cache to quickly identify the sub patterns that I need to call in an arrangement together to find the shortest sequence that would call that code. And in this way, when I repeat this for my all 5 codes here that are given to me in puzzle input, I should be able to find an answer very quickly. So yeah, folks, that's my thinking process right here. And I'm going to do that. Probably should be very straightforward because I was able to find this sub problem in my part 1. And I think this is going to help us. Else, I think we would have spent, if we would have done brute force, we would have spent a lot of time thinking about how to do it. Because this, my friends, is not a problem you brute force. It will probably take, I don't know how long, probably more than more than your age or your time left on this planet to calculate this using brute force. It's that complex. And this is the interesting things about the programs where the complexity goes exponential very quickly. But yeah, with that, I'm going to go ahead and write some code. And I think you should also try doing that and do some hit and trial, try to see what happens and try to put some debug points and understand how you can make the code more optimal. And the idea is you have to identify the sub problem and then you have to identify like what are the paths that are being repeated. And if you can just put them in a cache, because storage is always going to be very cheap compared to compute, which is the times complexity versus space complexity. And yeah, once I'm back, we'll talk about retro, like what I could have done better. But I'll see you in a bit. And hey, welcome back. As you can see, we have received our second gold star, and with this, we have completed our day 21. And I followed the exactly what I discussed. I already had code, which was initially written in a more iterative manner, but I wrote it more recursively, where I can generate a problem, and from that problem, I just kept calling it recursively the subproblem to keep generating the sequence that we want. And I put like memoization, where I would just pass on a dictionary of like what all we know, so that we don't have to do the BFS again and again to find the patterns here, as we discussed in this one. And that made this problem really easy to do in part 2. But I ended up spending over 1 hour in part 1 just to write that in an optimal way. So it's basically like a tech kit, depending upon where you want to put the effort and make the problem more optimal. But this was a really fun problem. And I can see that if we wouldn't have found this sub problem, we would have really struggled with it, trying to solve it in an other way. And this is the beauty of solving these multiple problems, because they end up almost touching up on every surface area of programming, where you end up doing from string manipulation to graph traversal, greedy approach, divide and conquer. And here I think like a classic DP problem, where we have to find the sub problem and add memoization to make it a lot more efficient. But with that, I think we are at the end of day 21. And yeah, I'm still playing catch up. The 23 problem just launched like few minutes back. So I have to record the videos for the next 2 problems. And I'm planning, I think since this is a Christmas week and I don't have work tomorrow, I will probably quickly record 2 videos and then record them, edit them, and get it to you guys. But yeah, let me know how you solve this problem and how are you finding this series. And if you like this video, please like the video below, share it with your friends, and subscribe. It only takes few seconds, I promise. And with that, I would see you in the next video. Take care. Bye-bye.